Ladies and gentlemen, you are welcome to today's tutorial, and I'm excited to share the crucial tool that I have identified as indispensable tool for every university student, regardless of your field of study. That is whether it's business administration, management information systems, computer science, or any other discipline, particularly engineering. The tool in focus is trigonometry and its identities, as you can see over here. So in today's section, we will dive into the essentiality of understanding the trigonometry and how mastering its identities is a game changer for we students. The ability to leverage these identities to express equations in alternative forms not only simplifies tasks, but also actually deepens your comprehension of the subject matter at hand. So now, what's on the agenda for this tutorial? For this tutorial, we will talk about the trigonometric ratios, the various trigonometric ratios that we have, and also explore the identities. And I'll try and help to provide the insight into how these mathematical gems came into an existence. So by the end of this tutorial, you will be well equipped to harness the power of trigonometry throughout your education journey, particularly at the university level. So now let's get ready for an enlightening exploration of this trigonometric and its identities. Now, let's look at something, the diagram that we have here. Let's look at the diagram that we have here. Let me label it A here, C, and B. Before that, let's look at the various trigonometric ratios that we have. We have three main types of trigonometric ratios. The first one I would like to talk about is the sine theta. The second one is the cos theta. And then the next one is the tan theta. This is the three main trigonometric ratios that we have. The three main trigonometric ratios that we have. So now let's proceed and talk about these trigonometric ratios. I'm fully aware that in your junior high school or senior high school education, you learn something called SOHCAHTOA. The X means sine theta, the C means cos theta, and the T means tan theta. The O and the H represents the ratio of that particular trigonometric ratio. For example, let's pick sine theta. When you pick sine theta, it's equal to opposite over hypotenuse. When we pick cos theta, it's equal to adjacent over hypotenuse. And when we pick tan theta, it's equal to opposite over adjacent. So as you can see here, the opposite is being represented by O, and then the hypotenuse is being represented by H. We do the same for cos theta, which is A, which is the adjacent, and then H for the hypotenuse. And then for the tan theta, we have O for the opposite, and then A for the adjacent. So to be able to remember this identity and their respective ratios, we have a short code that we have given to it, which is the SOHCAHTOA, meaning that the sine theta is opposite over hypotenuse, the cos theta is adjacent over hypotenuse, and then tan theta is opposite over adjacent. Now that we know this, let's take this diagram into consideration. This particular diagram up here, let me redraw it over here. Now, let's assume that the adjacent is A. Let's say the adjacent is A, the opposite is B, and then the hypotenuse is C. This is right angle triangle, and this is the angle under consideration. Where the angle is facing is your opposite. Assuming that we have the diagram as this, and then the angle is here. Now, if the angle becomes this part, then we consider this part as our opposite, and this part becomes our adjacent, and here becomes our hypotenuse. So now, because we are considering this diagram at my left over here, and the angle is at this point, we consider the B part or the B side as our opposite. So now let's clean this and then see what we can do for this right angle triangle. So considering this right angle triangle, you can see that the opposite has B, the hypotenuse has C, and then the adjacent is A. So based on whatever we have established here, we can come into conclusion that our sine theta is equal to opposite over hypotenuse, which is equal to B over C. Our cos theta is equal to adjacent over hypotenuse, which is A over C. And then our tan theta, it's also opposite over adjacent, which is B over E. So this is the three main trigonometric ratios that we have, and we are going to use these ratios to do a lot of things. So please take note of them. Now let's look at additional identities, which is the transform of these three identities, right? We are going to look at additional ratios, which is the transform of these main three ratios. Let's take tangent, or let's take secant, for instance. The secant is, this is the secant, is equal to hypotenuse over adjacent, which is equal to H over A, right? Or it's equal to, based on this diagram, is equal to C over A. And another one that I want us to look at is the cosec theta, or the cosecant, which is equal to hypotenuse over opposite, which is equal to, based on this diagram, C over B. That is hypotenuse over opposite. When you look at this one, you can see that the secant is the reciprocal of the cos theta, and therefore when you see 1 over cos theta, which is equal to this one over here, which is 1 over A over C, will give us C over A, and it's equivalent to sec theta, or secant. When we take the cosecant, which is the cosec theta, for this one, we can see that the result, the ratio, it's C over B. And when you look at the main three identities, we can have the one which is B over C, that is sine theta. And therefore, this means that this is the reciprocal of the sine theta, and it's going to give us C over B and equal to 1 over sine theta. So basically, we can establish that we have three main ratios that we are going to consider here. The first ratio is the sine theta, the second ratio is the cos theta, the third ratio is the tan theta, the next ratio is the sec theta, which is the cosecant, and then the next one is the cosec theta, which is the cosecant. So these are the 5 main ratios that we are going to consider in these tutorials, and we are going to use them to do a lot of things. So please take note of them, try to understand these identities and how they are being generated based on whatever we have done so far. Now looking into the last one, which is the tan theta, we can see that we have done the reciprocal for sine, we have done the reciprocal for cos, and then we left with the tan theta. The tan theta also have its reciprocal, so For 1 over tan theta, it's also giving us a reciprocal of cot theta. And that cot theta is the same as A over B. Looking at the tan theta ratio, it was B over A, and therefore the reciprocal, it was A over B. This is also the trigonometric ratio for the inverse of the tan theta. And this adds up to the ratios that we have already mentioned, which makes it 6 trigonometric ratios. The first 3 is the main trigonometric ratios, and then the second 3 is the reciprocal of the main trigonometric ratios. Now, let's also look at some few things that you have to know. Aside knowing that this is the reciprocal of the main trigonometric ratios, we can also establish that when you divide two trigonometric identities, you end up getting another trigonometric identity, or the inverse of another trigonometric identity. Let's take a look into that. Now, we were able to establish the fact that the sine theta is B over C, and then the cos theta is A over C, based on this diagram over here. And therefore, when I'm dividing the sine theta, which is B over, that is the sine theta, B over C, and then the cos theta, A over C. B over C over the cos theta, which is what? The cos theta is A over C. This division or ratio is equal to sine theta over cos theta. So in simplifying this one, we are going to get B over C times C over A. And therefore, when we simplify, we are going to get B over A. Let's look at the identities or the ratio that I've mentioned already. And then let's see which one goes along with this result that we have gotten. So let's look at where are we going to get B over A. The B over A is tan theta. That means that B over A is equal to tan theta. This shows that the tan theta can also be written as sine theta over cos theta. This is one thing that we have to also take note of. Let's look at the next one. When we divide cos theta over sine theta instead of sine theta over cos theta, we are going to get something like A over C divided by B over C, which is going to give us a result as A over C times C over B. And at the end of the day, we are going to get A over B. Looking at this result, which one do you think goes along with this? For A over B, the one that we got for tan theta was B over A. And now we are getting A over B. This means that the reciprocal of the tan theta is the A over B. And as we established already, the reciprocal of the tan theta is the cot theta. And therefore, the cot theta can also be defined as cos theta over sine theta. So this is another one that you have to also take note of. Let's look at the next one. The next one that I want us to look at is the fact that the sec theta is equal to 1 over cos theta, and then the cosec theta is equal to 1 over sine theta. So let's take note of these identities. And in my next tutorial, I'm going to show you how we will deal or use these identities or these ratios. We will use these ratios to do whatever we want to do by coming up with various trigonometric identities. So thank you for watching, and I'll see you in my next tutorial.